Hey students, I got this new whiteboard, so this is how I'm going to be doing lessons from now on. Hopefully it'll be a little more helpful going forward. Today, we're going to be continuing down looking at radicals. And like we did yesterday, we're going to look at non-perfect roots, but we're going to look at some more complex versions of non-perfect roots that you're going to be seeing more as we go forward in algebra, that are a little bit more difficult than the ones that we did yesterday, but ultimately are the same process. So, if you'll remember, yesterday we had something like the square root of 20. And we said the issue here is that 20 is not a perfect square. There's not some whole number, some integer that you can multiply by itself to give you 20. We know that that's the issue here with the square root of 20. But there is some number, we just don't know what it is. It's just some number with a decimal / fraction. And we figured out yesterday how to break this down into a radical, a simplified radical. And today, what we're going to do is we're going to look at non-perfect square roots that look something more like this. So what if you saw 3 times the square root of 20? Now remember, 3 times the square root of 20. When you see a number next to the radical sign, the multiplication is implied. Just like when you see something like 3 times 5 in parentheses, we know this is actually saying 3 times 5, even though there was no multiplication sign there, right? We remember that just from all the math that we've done over the years. So, this is saying 3 times the square root of 20. Now, momentarily, let's just ignore this 3 here for a second, and let's look at the square root of 20. And let's say, okay, what did we do yesterday to simplify this radical? Well, for starters, we need to break it down into factors. Now, you have some options here. You can break it down into its prime factors, which is always going to work. That'll always be a good step. Break a number down into its prime factors. But if you don't know any prime factors, or in the process of breaking it down into prime factors, you know that there's a set of factors that multiply to be 20, where one of those numbers at least is a perfect square. Well, then that's the faster and easier way. So in this case, the square root of 20, we know that to get 20, we can multiply 4 times 5. And 4 is a perfect square, right? Because 2 times 2 is 4. So we can rewrite this expression as 3 times the square root of 4 times 5, like that. And then we know that through our exponent properties that we have 3 times the square root of 4 times the square root of 5. And then we say, okay, well, the square root of 4 is 2, right? So this becomes 2. So we have 3 times 2 times the square root of 5. And then what we can do here is 3 times 2, we know that is 6. So this equals 6 times the square root of 5. Now, you need to get this written down, pause the video, and write it down for your own reference. I'm going to take a drink of coffee, and then I'm going to erase it, and then we're going to do another one. Let's say this time we had something like 5 square roots of 56. 5 times the square root of 56. Now, if you heard, the first thing I said was 5 square roots of 56. That's another way you can read this, or 5 radical 56, or 5 times the square root of 56. You can say it any of those ways, they all mean the same thing. Now, just like we did last time, step 1 is to simplify the radical, what's under the radical sign. So, 56. Now, when I'm thinking about numbers you can multiply to get 56, I can't think of any perfect squares off the top of my head that go into 56. Well, hold on. Actually, I can. Can you? Pause the video for a second and think about it. I can think of a perfect square that goes into 56. Tell me this. 56 Is that not 16 times 4? It is 16 times 4. Sorry, it's not 16 times 4. That's 64. My apologies. Look at that. Even I make mistakes, and I'm not going to edit it out because that takes too much work. So, not 16 times 4. Let's go with 7 times 8. 7 times 8. Those are two numbers you can multiply to get 56. Not 16 times 4 once again. Sorry, I was wrong. So, 7 times 8. So, let's rewrite this as 5 times the square root of 7 times 8. 5 times the square root of 7 times 8. So, one of these numbers can be broken down again. 8 is not done being broken down, and we have nothing. We have no perfect squares yet. We don't know what we're doing. So let's break 8 down again into 2 times 2. Sorry, 2 times 4. I got quarantine brain, guys. 2 times 4. So this, once again, will be rewritten as 5 times the square root of 7 times 2 times 4. Now we're talking. Now I see the light at the end of the tunnel. And why do I know that? Because I see a perfect square here. 4. 4 is a perfect square. Remember, this entire expression can now be rewritten as each of these under their own separate radical signs. So 5 times the square root of 7 times the square root of 2 times the square root of 4. One of these is a perfect square. The square root of 4 is a perfect square. We can solve that. The square root of 4 is 2. So that 2 now comes out. And we get, what is 5? We get 5 times 2 times the square root of 7 times the square root of 2. Well, square root of 7 times the square root of 2, using our exponent properties, we know that this is going to be simplified as the square root of 14, because 7 times 2 is 14, and then 5 times 2 is 10. The 10 times the square root of 14, and that is the final simplified version of 5 times the square root of 56. Now pause this video and write that down. Let's do one more. And this one, I won't make any mistakes in. Let's see. I'm trying to think of one off the top of my head. What if we did 7 square roots of 63? Okay, pause the video. Try and do this one on your own before I do it. 7 times the square root of 63. All right, so the square root of 63. What are 2 factors you can multiply to get 63? Well, fortunately, I know off the top of my head one that includes a perfect square. 63, 2 factors you can multiply are 7 times 9. 7 times 9 is 63. So 9 is a perfect square. So this can be rewritten as 7 times the square root of 7 times 9. 7 times the square root of 7 times 9. Now, we can rewrite that as 7 times the square root of 7 times the square root of 9. 7 times the square root of 7 times the square root of 9. One of these is a perfect square. The square root of 9 is a perfect square. That simplifies to 3. So that 3 now comes outside the expression, and we get 7 times 3 times the square root of 7. Well, 7 times 3 is 21. 21 times the square root of 7, and that is your simplified version of what we started with.